The first thing to do with limits is take this number, which is a 1, and substitute it in and see what you get. Well, what we would get is a 1 minus 1 for the numerator and a 1 minus 1 for the denominator. So that would be 0 over 0, which is undefined. So the next thing to do is try some algebra. So we've got the limit as x approaches 1, and this can be factored as x minus 1 times x plus 1. And then you may remember from intermediate algebra that this can be factored as x minus 1 times x squared plus x plus 1 from the difference of cubes formula. Well, what if you didn't remember the difference of cubes formula? Is there some other way to do it? Yes, there's a couple of other ways. And this formula, difference of cubes formula, only applies if these are cubes. So what if this, instead of being a 1, was an 11? Then difference of cubes formula is not really going to help you. Or what if this was x to the 4th? So we need some other way to do it. By the way, with this one back over here, once we do have it factored, then notice that these, which were the factors that were causing 0 divided by 0, those disappear. Those are canceled, and we can very easily get a solution after that. But back to this idea, what if you didn't remember how to factor that? Well, one other possibility is you could look at this and say, well, it's x minus 1 that's really causing the trouble, and the only way I'm going to get it to cancel is if there's an x minus 1 that gets factored out of the top. So you could then say this one can be factored out of it. That means that it will divide into it, much like if you have a 12. And you say, well, I can factor this as 3 times 4. Well, if 3 is a factor of it, then that means that 3 will divide into it. So you could take a 3 and divide it into the 12 and obviously get a 4. So factoring and dividing go hand in hand. So that means that if x minus 1 is going to be a factor of it, then we could divide it into it. So x minus 1 gets divided into x cubed minus 1. So an x dividing into an x cubed will go x squared times, and then distribute. So it's going to be x cubed, and then this times this will be minus x squared. And then subtract that line, and what's left over is an x squared positive and carry down a negative 1. Next, an x will divide into an x squared positive x times, and then distribute. So it's going to be x squared minus x. And again, subtract so that the x squares cancel. The x becomes positive, and then carry down the negative 1 one more time. And finally, it's an x minus 1 dividing into an x minus 1. That will go one time with a remainder of 0. And so we get x squared and an x and a 1, just like that formula did. So after that, we can try again, substitute in the number 1, and it's going to be a 1 plus a 1 plus a 1 for the numerator, and 1 plus 1. So it's 3 over 2. And then it's always a good idea to take a look at the graph and verify that we got it right. So the original one is x is cubed minus 1 divided by x is squared minus 1. And we're talking about where x equals 1, so the window should go something like 0 to 2. And the answer is 1.5. So going from negative 2 to 2, that should cover it. And then take a look at the graph. Oh my, the graph left a little hole in it, which is what we discovered when we substitute in a 1. If you substitute a 1 to the original problem, it's undefined. My graphing calculator rarely gets that little hole in the graph right. Anyway, the point of this one is, what if you were close? What if you were at 0.999? Then is the answer 1.5? Yes, it is. And on the other side, what if you were at 1.001? So very close to 1, but not exactly there. Then is the answer 1.5? Yes, it is.